Parvez, you are on
Uh,
mute.
yeah. Hi, everyone. Good evening, and welcome to another webinar session of PMI UE chapter. I hope you are doing well. And yes, everyone, please write, if you don't mind, from which side, which country and which part of the Emirates you're joining. Hello, Shada from Dubai. So we have, yeah. Hi, everyone. Um, we have person joining from Spain, Madrid, Raul Martin from Spain, Madrid. Yeah, hi. Good evening, everyone. Thank you for joining for another webinar session of PMI UE chapter. My name is Parvez. I'm welcoming you to this webinar session, and thank you for joining this evening. So let me introduce you about PMI UE chapter. Okay, so we will go ahead with I'll doing the introduction of PMI UE chapter, then hand over the podium to our esteemed speaker for today, okay, Dr. Moin, and then Dr. Moin Aquib, and then we will be taking the question answer session. So let me introduce you the PMI UE chapter. PMI UAE chapter was funded in 1969 by a group of working project manager. 50 years, PMI is now source and resource of all things of the project management, and is one of the largest professional associates association in the world. Okay, and issues a globally recognized standard and credentials. PMI chapter offers a training and credentials and to the communities. PMI UAE chapter vision is empower and influence individual with the innovative project economy principle to turn ideas into the reality. And PMI UAE chapter mission is to disturb and create a value-driven opportunity to our chapter members and partners to become agile, innovative, productive in the platform for the growth and the project economy. PMI UAE chapter is run by 100% by the volunteers. We have 4,000 plus active members, ranked among the top 5 chapters in PMI EME region, and focused on the top leading industries and trend, serving UAE aspiring community of project managers, PMI certified holders, and project program professionals that are seeking the project management capabilities and offering and believing in importance of our professions. So PMI UAE chapter is led by our president Adil Sultan, marketing director Anjana, director of governance Jamna Jaber, director of community Wasim Haider, the director of events Bhavin Lad, director of volunteers Joel, and director of finance Hakim, and director of membership Fani Kumar. So what is the benefit of PMI UA chapter is networking, knowledge and learning sharing, career growth and events. So we as a networking, we do create a lot of collaborative and university and bigger organizations, collaboration with our industrial chapter, industry group community, online forum and discussion group. Okay, and so we do all this as part of our events. And we have also a members corner. Okay, so our members corners, and we have introduced member spotlight. So this you can share your to us, and we can write it to us, and we can to newsletter at pmiua.org, and we can include that into our monthly the newsletter which we share to all the PMI members. Do follow us on our social media and LinkedIn, Facebook, Instagram. We are available on Twitter, which is X now, and PMI UA chapter YouTube channel. And we also have a PMI UA chapter community, WhatsApp community. So as in YouTube also, we share our webinars, so are recorded and shared to the PMI chapter. This is about PMI UA chapter. Let me introduce you about today's our esteemed guest, Mr. Aquib Moin. Aquib Moin has more than a decade experience in astronomic and space science education, research, and outreach. He's passionate about multidisciplinary exploration of the universe, powered by emerging technologies such as AI, ML, resulting in solution development and problem solving back on Earth. As associate professor at the United Arab Emirates University, UAE, and senior affiliated scientist at the National Space Science and Technology Center, NSSTC, and he is contributing to the development and implementing of cutting-edge research program and educational program and outreach activity in the field of astronomy and space science. His core competencies include multi-wavelength astronomy, space science, space technology development, project management, and artificial intelligence and machine learning, powered by data analytics. He has also gained vast experience of designing and implementing educational program as well. About Aquib Moin, have worked with the prestigious institutes such as NASA JPL, Harvard CFA, and New York, Shanghai Astronomical Observatory, University of Johannesburg, such as Space Science and Curtin University, and published multiple papers. I'm also committed to sharing knowledge of expertise with the student. He's very committed knowledge sharing expertise with the student colleagues and publics. So I hand over this podium to Mr. Dr. Aquib Moin to take it further.
Thank you so much, Parvez, for that wonderful and detailed introduction. First of all, I would like to sincerely thank PMI UAE chapter for letting me have the opportunity to share some of my thoughts with you guys. I think that it is a different dimension of project management, which I'm going to talk to you about. But it's still project management, and we are exploring how this wave of AI and machine learning is facilitating the stuff that we do in space, right? So the centerpiece of my discussion is going to be around space missions. But then obviously, those of you who are from various different disciplines would be able to identify in a sense that, broadly speaking, you break down larger problems into smaller problems, and you can see that how you can manage things efficiently by not leaving behind in terms of applying what is inevitable today, right? So with that, I'll just share my screen with you guys, and then we can start this journey that I'm going to share with you. So while I'm sharing it, I'll just tell you a little bit about it. So it's still an ongoing journey, I would say. I'm not fully there yet. It's an exploratory kind of activity. So what I'm going to share with you today is something that I recently got involved in, being a part of the NASA's AI and machine learning working group for one of their newer missions. So it's an ongoing journey. I cannot claim that it is done or I have reached the peak of it, but then it's all about sharing whatever you have explored so far. and then enabling other people to, benefit from it as much as possible. Right? So my title says that how does project management evolve in this era of artificial intelligence, in particular when you are talking about space exploration? As I said, that we could talk about any other discipline and, the fundamentals or the larger scale picture would be similar. But the reason why I am invoking space exploration as the domain of discussion is because it's my background, right? So I don't know much about banking or finance or any of those other amazing fields. But I think I will try to make sure that you guys can at least relate with the broader strokes of what is possible these days. Right. So let me first give you a sense of what do I mean by AI for space project management, right? And as I said, the context here is my involvement in one of the newer missions NASA is working on these days. I cannot share specific details of that mission with you, but I think I feel that the broader learning and the experience that I had working for that is something that I can encapsulate in more generic terms and using space exploration as a metaphor or as an example. So I have lesser number of slides and lesser content on the slides because I would like you guys to imagine more, right? So imagine in your head when I'm speaking to you and when I'm trying to paint a picture, try to visualize that in your head as to what is the landscape we're talking about. So when we talk about space exploration, obviously it happens from the ground and from space. So I'm not talking about ground-based exploration these days, which is observing stuff using telescopes based on the ground. What I'm going to be talking about is missions or spacecraft or satellites that are launched into space for different kinds of purposes, right? In general, when NASA or ESA or JAXA or ISRO or the Chinese Space Agency, any of the space agencies or the UAE Space Agency for that matter, any of these agencies plan a mission to be launched into space, it actually has multiple phases. And a broader overview of those phases can be seen on your screen right now. So we start off with design and conceptualization. That is the phase which is largely trade space exploration. What are the mission objectives? How can we address them? How can we manage this entire complex project into, from start to the end, and from conceptualization to launch? And what are the key requirements and demands of that whole mission? That is the first phase. Secondly, we get into what we call the mission development, right? Broadly speaking. And in that phase, you are actually you locked on a design and a whole blueprint of the mission, and then now you start to develop the actual hardware, software, and all of the components of a mission. Then you move on to the launch of the mission. That again is one of the most critical phases, when you actually are ready to put your spacecraft in space. Then, once you have launched it, you start to operate that. Every mission has a lifetime of 3 to 5 to 10 years. Some missions are exceptional. For example, the Hubble Space Telescope is in operation for over 30 years. And the final phase of this whole project, which we need to manage, is data analysis and scientific interpretation. What is it that the mission is going to reveal to you what is the knowledge or the purpose or the services it is going to provide to you. So now I want you to imagine in your head all these phases stacked side by side. Running a space project is highly multidisciplinary. We need people from scientists, engineers, software developers, mission designers, strategists, all the way up to people from finance, business, accounting, and all. So it is one of those disciplines where almost every, if not all, almost every discipline can be imagined to be integrated, right? So with reference to what is happening at my end right now, with this project that NASA is planning to launch, the task was to take a look at this whole project holistically and see how AI and machine learning can help with the management of each and every phase that I described to you, right? So let's talk about these phases one by one and see how AI or machine learning or the whole AI enterprise facilitates, and we are exploring that it can facilitate each and every phase of the mission. So one thing I would like to point out before moving forward, I think, and this could be actually a separate discussion, when we talk about being AI ready or being AI literate in any discipline that you can imagine, what does it actually mean? Does it really mean that you have to try out tool after tool after tool, anything that pops up in the market, or keep on running after one model after the other model? Is it just about that? My answer is not exactly. It is actually about looking at the problem holistically and first of all, identifying what areas can be facilitated by putting an AI ecosystem. The emphasis is on ecosystem. AI ecosystem around it. It doesn't mean ready-made tools. It doesn't mean one model after the other. It means what are the requirements for that problem? What solution do you want to apply to it, right? So that was a discussion at NASA as well, right? So what we began to realize is that integrating AI into multiple phases of the project, it actually means enhancing the process which it takes to go from point A to B, number one. Then facilitating something which takes a lot of human effort and human hours, which is decision making, right? It will help decision making quite a bit. And finally, something where AI can really excel at if you have the necessary guardrails around it, is predictive analysis. It is something that is trained or that can be trained or fine-tuned for something which can make predictions based on existing knowledge, and it has access to a whole lot of knowledge, right? This is what was the first point that came up. Secondly, it actually streamlines scheduling, timelines, managing delays, and achieving time-sensitive targets, because you can delegate a lot of it in parallel where you would deploy humans. But again, the point here is it doesn't mean you are replacing humans. This is something that was specifically mentioned to us, that we are not talking about human replacement. What we are talking about is augmentation. It is going to empower the project managers and engineers and designers to enhance their productivity. It's not about who is going to replace what is it going to replace, and what who will be out of job. It's not viewed in that way, at least at NASA or where I am involved. Then the third point here, which was also considered, is managing the level of complexity or the layers of a project, right? If you are managing a project in a traditional way, let's take the space missions example. Imagine that a space mission is being developed, right? I'm talking about phase 2. What does it involve is design, manufacturing of components like chips or individual components, boards, design and development and assembly of what we call subsystems. For example, the communication subsystem on a satellite, a sensor system on a satellite that is going to observe something, and let's say, for example, the power system, right? So it is multidisciplinary, multi-layer problem that is very tedious to manage using conventional tools, right? So you can actually apply multivariable optimization, and you can actually model the problems beforehand, which you would do manually. You can actually have surrogate models that can, have these multiple iterations of design, and it can point out the points of failure, and it will minimize the complexity of, let's say, achieving the complexity of designing that or developing that hardware or software. And this is something I will come back to later. There is a huge, huge potential when it comes to the final phase of the mission, which is data analytics and interpretation. And this is something with which the data scientists among the audience can relate quite a lot. Right, so what are we doing with this AI integration right now? So imagine that we are in the mission conceptualization and design phase. In this case, we have a mission objective. Let's say, for example, it is a remote sensing mission, right? And its objective is, for example, disaster management, right? That whatever disaster takes place anywhere, God forbid, then this satellite mission is going to help facilitate the efforts to mitigate the damage. For example, locate survivors, estimate casualties, identify, the stuff that has not been damaged under the rubble, and also specify routes and positions and many of those things. So the first thing that we need to look for is what is the feasibility of that mission when it comes to the available technology, right? One way of doing it is that we access all these scattered resources here and there, 1,000 papers or 5,000 books or data tables and databases, or let's say, for example, JSON files and whatever form of data you can imagine or resource you can imagine. One way we realize that AI can help with this is that it could be a source or a tool for information synthesis, right? You can actually put together an ecosystem, not a tool. Remember that whenever I mention a solution, it is an ecosystem. It has multiple components around it. Imagine that you are deploying this function, which is information synthesis. So AI could be integrated into an ecosystem where it, let's say, for example, it has a retrieval based system. So you have a retrieval augmented generation that it fetches information from multiple sources, evaluates it using LLMs, does the required, let's say, information validation, and it provides you with this concise piece of information that actually a human would take weeks to do, right? So it means that if someone is exploring these ideas, the work that he might do in 6 weeks would be done in, let's say, 1 week, right? So it is augmenting human capability, right? In the same way, you can optimize things that you can I mean, you can obviously automate that using a standard computer system, but then using AI or machine learning, you can train models to uh, pinpoint anomalies, for example, in the orbit of a satellite. That what is the likelihood of this anomaly? One anomaly could be that the satellite is supposed to be at 400 kilometers. It will drop down to 350, right? So you will see an anomaly in the orbit. That is something that you can implement. So looking at this from a project management standpoint, imagine that there is a project manager that is responsible for the mission conceptualization study. How many elements of this project can be facilitated by AI and machine learning? I just gave you a couple of examples, and there are hundreds of them. So because just to preserve time, let me move forward. Another enormously important area that we explored that can benefit from AI and machine learning. And this also could be relevant to other projects. I mean, for example, engineering projects or manufacturing plant and whatever. So when we talk about space missions, right, now let's talk about the phase where we are evaluating the risks and we are trying to reduce uncertainties, right? So in that case, the uncertainties could be, number one, you have an environment outside of Earth which is not very friendly for spacecraft. Secondly, you have exposure to much higher levels of radiation as you would on the Earth's surface because you are beyond the protective layers of the atmosphere. Then your mission is a remotely operated vehicle. So it can run into malfunctions or stuff like that, right? And let's say, for example, you are tasking the mission to look at a disaster-ridden area. It is possible that the scheduling of the mission went wrong and you want to mitigate that thing. So there is a whole mission assessment, risk assessment phase of the mission, which again is obviously a sub phase of that project or a project itself. In that case, we realized that based on historical data or based on custom tuned AI models, which could be trained on the conditions of the environment that are known to us, we can do a lot of predictive analysis and validate that using something, for example, like Regus framework. I mean, this is something that I worked on recently. You can actually validate your assessments based on AI-based systems, and another key aspect of it is that you can do it much faster, right? Much faster. So there's a prayer call. Let me just pause for a second, a couple of seconds. All right, guys, don't worry. I stopped for just a minute. There was a call for prayer. So I'm back, and thanks for all of you. Thanks for your interest. I'm really pleased to see that you are enjoying the talk. Anyway, let's continue. So what I was saying is that uh, there is a huge problem of mitigating and risk assessment, which AI can facilitate. For example, uh, as I was mentioning, that you have risks of your spacecraft being subjected to harsh conditions in space, right? So, and there's only so much scenarios that you can run in a manual or a traditional way. Generative AI, for example, such as GANs or VAEs, would allow you to run multiple scenarios with multiple parameters at the same time, and also higher dimensional analyses, which will help you see or project much more clearly where is your project is going to face the most risk, right? So I think I spoke enough about it. We can come back to it, but let me move on. Now, so now we are at a phase where we are actually developing the mission itself, right? We are project scientists, we are project engineers, we are project managers who are responsible to deliver that mission. So imagine that there will be aspects of this mission which will be very different from other projects, but at the higher level, you need to meet schedules, right? You need to optimize resources. You need to identify dependencies. You need to, test and validate. So what we explored as we were working on this NASA project is that we can actually optimize scheduling based on the predictive power of AI to see what is the projection of what is the progress of the task, or a projection of, let's say, an aspect of the project as a function of time, right? And it can be based on all of the known parameters that you can feed into an AI ecosystem, right? In that way, you can also dynamically assign resources, based. So that is where the decision-making element comes in. So we also identified that you can optimize your resource allocation by using AI or machine learning based predictions, in a sense. Before I move forward, there is a bonus for all of you who are listening to me. I will show you a glimpse of one of my projects, one of the elements of my projects in the end. I think I did not have it on the slide, but I can just show it to you, just to give you a sense of what do I mean by an AI ecosystem. One thing that space projects or space project management can benefit a lot from AI integration is the automation of testing and validation, right? You can actually train AI models with testing protocols, right? And validation mechanisms, which would be able to run all those possible tests for you. And it can give you higher level of precision for mission critical systems. It can increase the efficiency, and it can also reduce the chances of error, because it can avoid human error, right? And obviously, all of that results in accelerated implementation. The stuff that you would be able to do in a much longer time would be able to you would be able to finish that off on a much shorter time scale. So this is where things also get more tricky. The time when you are done with the mission development phase of the project and you are getting into the launch of the mission, operations, and making sure that it keeps on running properly, which is essentially done from the ground. And it is a question of how far you can go with autonomous operation, but this is what we're getting to, and I will come back to that point in the end. So what is becoming increasingly interesting for space agencies, and that also is being explored at NASA, is predictive analytics for mission critical monitoring, right? As I gave you an example earlier, one thing that we need to ensure as part of managing this project in space is that it remains within the specifications. What those specifications might be, it has to be in the right orbit and in the right orientation, right? It has to be constantly or based on the requirement in touch with Earth. So the communication link should be intact. And it should be able to withstand the conditions which it is in. And it is also need to be equipped to deal with rare events. For example, there is a solar flare that we were not expecting, right? And it actually enhanced or increased the amount of energetic particles in the atmosphere, and that suddenly goes over the operational ranges of the instruments on the spacecraft. That is again is going to cause anomalies, right? So what we are exploring is how you can leverage predictive analysis using, let's say, for example, isolated forests prediction. That's one example, or random forests, or decision trees, whatever, or even XG boost. I'm just giving you some examples. We can actually design predictive elements, predictive analysis based on the features which we have the best knowledge for, right? And based on the ability, again, I'm just being a little bit, highly optimistic. It is not that easy. Based on what we know about the conditions or the known variables, we can have those features with which we can predict the elements which might be of trouble for the mission, right? And that leads to forecasting, and that forecasting leads to lower downtimes, right? That can lead to lesser amount of effort required to maintain. Let me give you an example. A project manager who is responsible for the operation of the mission, you would call him an operations manager. If they notice that the satellite is not at the right orbit, it is fluctuating, right? So it means that they will have to command the boosters or thrusters on the mission to adjust the orbital height, right? So if you have predicted that kind of fluctuation or variation, you can try to fix that over a period of time, and you can save some fuel by which might be required for drastic corrections. So your corrections could be continuous and gradual rather than a drastic correction. In that case, you are saving resources which are limited on a spacecraft already. And that leads us to something which is being discussed quite a lot, which is autonomous operations. How much autonomy AI can enable on the spacecraft. For example, if you have a rover which is driving around on Mars, it would have to make a lot of decisions autonomously. So there could be, with the current wave of AI, that could be managed through, let's say, analytics, which are derived from a predictive analysis, right? So that is something that we have been looking at. Then, as we move forward, we find ourselves with the data. This is where the data scientist in the audience would be able to relate quite a bit. So the obvious outcome or the output of a space mission would be in the form of some kind of data, right? Some kind of data. And even before you get into having quality data for your actual mission objective, you need to analyze a lot of data to actually validate that your mission is working fine. That is what we call the housekeeping data, for example, right? The levels of temperatures, the levels of, let's say, radiation, the state vectors of the satellite, right? The speed of the satellite, all of these kind of the orbital elements. So a lot of that data that you receive, which is housekeeping data, can be analyzed, let's say, using an AI-based ecosystem for pattern recognition. This was done, let's say, I wouldn't say in a really manual fashion, but then it can be done much faster and with much higher efficiency, and with the let's say, for example, algorithms that are much more clever. So you can have pattern recognitions, whether it is image data or whether it is time series data. You can identify patterns and you can classify, and many of you might be, I'm sure would be familiar with the supervised or unsupervised learning. You can have things applied, like, for example, classification of the types of events that you are looking at, right? You can also look at anomalies, as I mentioned before. So based on that, you can manage your mission for AI-driven scheduling, right? For example, if it is going through a storm of particles, AI can make a decision that it is not a good time for it to observe because the instruments will be overloaded. In that case, it would set a priority that, move your observations later on, right? Or you can do parallel workflows, right? And you can process a lot of data on orbit, right? You can do this automated AI-powered filtering with which you can reduce the resources that would be required to have all of that data downloaded, and then you filter it out. You can just, discard and throw it away. So there is a lot of stuff happening at within the domain of data analytics. And this is something which crosses boundaries with, processing any kind of data, other forms of data as well. So this is, again, a very active area that we're exploring, that what aspects of the operation can be facilitated with AI-powered analytics. So as I gave you a few examples. And as I said, I can talk a lot about each and everything, but, in the interest of time, I'm trying to be brief, and, we can talk more during the Q&A session. Finally, and I will go back and forth a few slides because we still have some time. What the scientific community is excited about is the enhancement of the discovery potential of the missions. What do I mean by that? So I think all of us, in this webinar, we do have some fascination around the mysteries of the universe, how things are going to evolve, what is the future going to look like, what changes the Earth can experience, how is climate change going to treat all of us, what is the effect of different kind of objects on the Earth. So those are the things which are the questions that we attempt to answer using a space mission, right? And there is a lot of stuff that is already helping the scientific community to enhance the potential of discovery or enhance the potential of capturing things that we might otherwise miss out, right? And this is an example that I will elaborate it more here. So now imagine that we have looked at um, the housekeeping data, we have evaluated, we are in the phase of the project now where we are going to manage the outcomes. Again, it is all like any other project management task, right? It is managing the outcomes, how you can amplify your outcomes, and how you can make sure that you get ROI or return on investment, because a space mission can cost anywhere between $100 million. I mean, a larger mission, $100 million to a few billion dollars, right? So you are looking at ROI. Right. So imagine that once we are done with the project evaluation and validation that everything is working fine. Now we have what you call the science data, or the user data, whatever data that is. For example, in case of GPS satellites, or in case of navigation that we use on our phones using Google Maps, it is position data, right? It's not exactly. I mean, it's a service that GPS provides to the users. So I'm talking about the output data, which is supposed to be the actual measure of the success of the mission. So imagine that we have an astronomy mission, right? And the purpose is to find out whether there is life on another planet. You might think that that is a science fiction or a filmy question, but it's no longer the case, right? Because, just for your interest, based on the previous missions that we have detected almost 6,000 planets outside of our solar system, right? And the search is now on for some of those planets, being habitable, whether they can host life or not. So imagine that you have enormous amount of data on these planets, right? And you're looking for signatures of life, right? So the problem is those signatures could be buried in the noise. That's one thing. Those signatures could be aperiodic, which means that you cannot really identify them based on just the idea of periodicity, that you see it again and again. Or it could be, someone could imagine, or it could be mistaken with an anomalous data point, right? So in that scenario, the AI-powered anomaly detection and pattern recognition comes in handy, because the valuable signatures which a human analyst might miss out on or discard it based on, let's say, similarity with some noise signal or something like that, you can deploy rigorous algorithms in the case of this science data, right? Which is again trained on rigorous predefined conditions. And it also facilitates the human analysts to do that much more efficiently. For example, imagine that there's a NASA mission or any mission which is producing hundreds and hundreds of terabytes of data per day, right? And you are supposed to look for a needle in the haystack, right? So it is an obvious use case for a machine learning algorithm for, first of all, clustering or classification, or anomaly detection, that how exactly there is something which is abnormal. So that is one use case. The other use case in this case would be dynamic allocation of resources. Let me give you another example. Imagine that by deploying a machine learning algorithm, you identified something really spectacular about one object that you're looking at, right? So if you miss that, you will keep on observing all of the other uninteresting or insignificant objects, which might not have that value. So if you have this mechanism wherein things of priority can emerge, you can reallocate your resources in real time, or at least near real time, to dynamically look at the object of interest. That actually optimizes the mission observation schedule, right? And at the same time, it leads to a higher percentage of discovery, because you might be looking at a number of things which you would otherwise miss out. One more thing, the third use case that I would like to bring up to you here, from the standpoint of being a project engineer or a project manager who is responsible for proving that his mission was, or her mission was, worthwhile. One thing that we also sometimes struggle with, and this is a problem in general, not necessarily just for space exploration or astrophysics, it is relatively tougher for humans to map out all possible insights across different disciplines. Let me break that down for you. Imagine that I gave you an example of a space observation, which is of a planet, for example. Now you see that there was a signal from it, which might be a signature of water, right? Or it might be a signature of ammonia or hydrogen sulfide, whatever there is. It is not easy for people or scientists to cross-reference that with existing knowledge from, let's say, for example, chemistry or biochemistry. So this cross-disciplinary synthesis can be made much easier by deploying this kind of an AI ecosystem, which can process and access the relevant context from different disciplines and build a much more comprehensive picture for you in a more time-efficient way. So this is what we call the cross discipline information synthesis, right? This is what is something which is, I imagine in my mind that this is something which is going to be groundbreaking. that at this, for example, I am a planetary scientist. I don't understand chemistry very well. I just understand a planet, its properties. I don't understand chemistry well. Or I am a chemist who doesn't understand planets well, right? So in that case, AI-powered ecosystems, which are equipped with right type of information resources, which can be retrieved in some with some mechanism. In that case, you can also enhance the outcome of your project by deploying those kind of tools, right? And so this is kind of like an overall picture. Let me just relate it back to the project management aspect. Let us go back to, as I mentioned to you, as a bonus, in the end, I will show you a snapshot of one of my projects that I've been working on, which is exactly about information synthesis using RAG-based retrieval and LLMs. Let us get back here, right? So what I just explained to you brings me back to, let's say, square one, right? So imagine that a complex project that starts from imagining a scientific or technological question or providing some kind of service, like, for example, GPS, like, for example, space-based imagery or something of that sort, and going all the way to think about it and to schedule it and to task people and to manage people and to ensure that the project is managed in a way that resources are optimized, time is managed efficiently. So what the conclusion that I'm giving you is that it actually basically, in one way or the other, facilitates the management and the management efficiency enhancement of each and every phase of a space mission. Now, think about it. You can map that onto something else. So I think what needs to be done is first to have this holistic view of the entire landscape. And this is something that I'm trying to share more and more with people, because after going through all of that, because you know what? One thing that I would also add here before I forget, I talked to you about multiple use cases and multiple phases and multiple elements of the project. But you know what? What we realized after going all through all of that, what I start discovering and start advocating, that there could be a central core of this ecosystem where resources and algorithms and the connectivity and all of the things can reside, and it will branch out to, let's say, different phases of the mission based on the requirements. So with that, you also reduce redundancy. In some cases, you want things to be redundant, but in some cases, you don't want, where you are wasting resources with duplication. So there could be a core AI, which is not necessarily thinking about an AI tool, right? That, okay, I will use this productivity tool to, let's say, enhance my, a portion of my work. It is not, as we are moving forward with this AI wave, my assessment is that it is going to be more and more about holistically integrating AI and machine learning based ecosystems, not individual tools or utilities, to larger scale projects. And the job of the project managers would become much more to identify all of that right at the onset. The integration is not going to happen as you move forward. it happens right at the beginning, right? This is what one of the lessons that I learned from it. So that's the primary thing that I wanted to emphasize. And the other thing that I would also like to highlight here is, I think, the question of why. Is it because just that AI and machine learning are buzzwords, or they are the new wave, or is it just hype? My response is, it's no longer hype anymore. It is the same thing that it was at the time of the dot-com boom or the internet boom. People did not imagine at that time, I'm not that old to, see, I mean, I have seen the established phases of it, but I cannot say that I was, I witnessed the emergence of internet from scratch. But so eventually what it will become is not a race of better and better models, not running after one after another tool. It would eventually be about human creativity augmented with AI-powered ecosystems, which are interconnected components that tackle projects, different components of the project or different parts of the project across the entire landscape. So this is what I envision. In the end, as promised, let me just show you one example or one use case of what I had been working on. And then I guess we can open up the question and answer session a little bit earlier, right? So I'm exiting this. I hope I still have all of yours attention. Let me just take you to an example. As I said, for obvious reasons, I cannot share a lot about that project that I'm working on, but I can, show you something generic that I did at my end. But it is an example of the work that I had been doing. Take a look at this. I think I stopped sharing. Let me share my screen again so that you can see what I'm talking about. There you go. So I'm showing you a part of the information synthesis system that I had been working on. I'm stopping at a moment because now we are trying to identify what next. But this is something that shows you a way to imagine information synthesis using an AI and machine learning driven system, right? So you can have your inputs, which is what is it that you want to achieve? What is the context of your work? Then you could have this database of information, or you could have a pre-trained model or a custom trained model. It depends. I'm not going in specifics. And then you can have this mechanism of asking the LLM, or in this case, you can also apply the small language models to synthesize and verify information in order for it to make sense and also be valid. So I think what I also did, what I also advocated and I promoted quite a lot, that you know what, in organizations these days, and I think some of you might have seen this, there is again a question of trust, ethics, and credibility on AI-powered solutions. There is level of resistance in organizations, or if not organizations, then people, right? I think that problem in a project management setting can only be solved if you have robust evaluation and validation, right? So it means whether you are working with a large language model or you are working with a retrieval augmented system, which is commonly called RAG, you need to deploy a metric-based evaluation system that would raise people's trust on the outcome. That's a separate discussion. I can just give you a separate seminar on how to validate the outcomes of an AI-powered solution for any kind of project, right? It's a general discussion. It's a different discussion. So I don't have time to do that. But I'm just showing you here an example of a piece of work for the mission that I'm talking about. So this information synthesis engine, I will leave you with this thought here. Imagine that this is one block. Then you can synthesize that information and feed it into the design simulation. Imagine how much it is going to accelerate the process. And from these design simulations, you can actually choose or select or optimize your designs, whatever you're working on. And eventually it becomes like a web of efficient AI. I don't like to use the word agents necessarily, AI components of a larger ecosystem that are going to propagate all across your project landscape. It's the entire, it would become an organism. It will become an entity on its own. So if you imagine it that way, I think it is going to make a lot more sense to you and to people you might be working for, and project upon which you will be implementing AI-powered solution on. All right. I guess with that, I can take you back to my slides, and I can attempt to respond to your questions.
Thank you, Akib, for a wonderful presentation. Yeah,
Thank you so much. I was just going to say that thank you very much all for listening. I will leave you with this one slide, however. Sorry, Ankur.
Yeah.
That what I just talked about is what people are exploring, right? But a lot more is coming up, right? For example, I just gave you a brief example on autonomous systems which are on orbit already. And that means that you are going to enhance, let's say, for example, you think about space travel, right? You don't need to rely on Earth-based systems and adaptive systems based on changing conditions. So this is what we are heading towards. Sorry, Ankur, again, for jumping back in. So I think with that, I would conclude my talk, and I'm open for any questions or discussions that you might want to have.
Yeah,
Thank
we
you so
got
much.
questions from the attendees, and we'll sure have another webinar from you, as you mentioned. So we'll take further questions. There is one question from Benil. As space-based activities are calculation-based, I mean, it's based on maths, physics. And so how is the value of any calculation or metrics is cross-validated, like distance, time, speed? He has given some parameters. He means that how you basically confirm that the value is correct.
That is exactly what I was talking about. That's a good question. You know what? I think, imagine that we now know that, let's take a very common example. Even if you ask ChatGPT to make a calculation for you, right? And based on the data, the enormous amount of data is trained on, it can provide you some sense of that calculation or any other LLM. But then, can you feed that directly into a critical mission component? The answer is no, right? The answer would be that you would come up with something like a physics-informed neural network. That's one example of what we can do. That you have this physics-informed, a physics-integrated model that is based on the real values for what exactly you would expect from this calculation. And that also can be, what we are also looking for is cross-validating that with historical data. So again, to answer that question, there are these multiple ways of cross-referencing, evaluation of results, and validation based on the expected answer. And then, the model, I mean, one area of working is how do these models evolve, right? We know that once a model is trained, it is a static piece of, it's a static model. And the other thing that you can do to it is that you can retrain the model with new information. But then how would you design a system that can evolve on its own? This is the direction where the cutting edge research is, right? It can evolve based on what I call a feedback mechanism, right? So you can feedback, and that's the example of that you saw in my system that I showed you, that you are kind of bringing back all the responses and you are cross-validating that, and you are, let me just say this because I might, be going a bit deeper. You can do reinforcement learning, RL, right? You can reward the model in some way for getting the right answer. So every time it learns and evolves with that. So I think that is a short answer for the question.
Yes, thank you for answering that question. Another question is about the confidentiality. So how do you, I mean, for example, it's from Benil. So Benil question is, AI, how does the proprietary and high confidential configurations are maintained, as Gen AI are always watching and learning? So do you think that high change of data leakage is there, or I mean, is there a
Yes.
way you just?
Yeah. I think that's one of the major concerns at these larger scale entities, for example, NASA, that how do you ensure data security? How do you ensure that the information is contained? So I think the answer, you're right that it is a concern, but what I would say is one word: customization. So if you talk about in a generic sense, you talk about all kinds of LLMs being produced by different entities, Meta, Google, OpenAI, or Anthropic, whatnot. They are all throwing out. So there are proprietary models, which you will have to pay to use. And then there are open source models. For example, Meta mostly releases open source models. And you can even go one level down. You can just have models with which you can even get the weights for that model. So I think what I can tell you, without going in too much of detail, NASA would probably have its own LLM, right? They have their own bioencoders, which is custom trained and which would be in-house. So that ecosystem. So I think you can imagine it as an ecosystem within the confines of an organization. And then it would be a question of what is it. So in my opinion, it should be a matter of choice for the organization what to share and how much to share. And the answer is more and more customization and tailored solutions which are in-house, which are not hosted in public domain.
Okay. Thank you, Akib. So next question is, how would you measure ROI for a space mission? This
Say
is
it
from
again.
Kareem.
Say it again.
Yeah. I mean, how would you measure the ROI for a space mission?
Okay. That's a question for the finance guys. But let me give you a distinction of what do we mean by ROI in the space sector, right? So there are 4 or 5 categories of missions that are launched by various kinds of entities. Number 1, purely scientific and exploratory missions. For example, the Hubble Space Telescope. For example, the James Webb Telescope. So they are not going to have any kind of ROI in monetary terms. I mean, there is a possibility that, NASA or some other entity would, put a pricing model on it, but, it's usually publicly available data. So the ROI in that case is not measured in a monetary sense. It is the enhancement of knowledge that comes out of it and how it becomes applied knowledge, right? For example, let me give you a very good example. People might say that, okay, if I'm going to measure a star and I'm applying the theory of relativity to it, how does it benefit me as a common person? The answer is, since we have been able to scientifically measure relativistic effects using telescopes, now that is applied to the GPS satellites to make sure that you get the precise position on the ground. For example, if you have Google Maps and you search it and you try to find out that how do I get from Abu Dhabi to Dubai, right? So
Yeah.
Imagine that you get an error of 50 kilometers. How would that work for you? It is going to be a disaster, right? We are only able to get accuracy of meters because we understand relativity. So in that case, the outcome of a purely scientific mission would be measured in the knowledge that is eventually applied. That's one category. I can go on and on, but let me just finish the answer. The second category is a service-based mission. That is something that earns money. For example, telecommunication satellites. The UAE has 6 telecom satellites, and the function is to provide telecom services, broadband internet, television channels, radio channels, secure data transfer, financial transactions, and they charge for that service, right? Similarly, there is agency-oriented missions, or let's say, for example, broad spectrum missions like remote sensing, for example. In that case, not all the services are free. So in that case, you can measure the outcomes in terms of money, how much you were able to make. But again, to answer your question, the ROI is determined in different ways depending on what was intended and what justified that mission in the first place.
Thank you. Akib, we are in short of time, so we have a lot of other questions, but I'm so sorry to attendees that we can't take all the questions now because of the time shortage. So what we'll do is we're going to share this all questions with Mr. Akib and we'll reply to on your email IDs. So thank you, Akib, for sharing a wonderful knowledge about this project management actually, but according to the space. And I think we are working on the same things, but the domain is different, and we have learned about the case studies, what you guys are working on. And I know it will be very nice to work on these kind of things.
It crosses boundaries all the time. As we do more webinars, another topic that I can propose to you is how domains cross each other, how something applied for space can be applied to an organization, let's say, selling software or whatever. So that is another topic, but that was my intention. I'm glad that you said that, Ankur.
No, we're surely gonna add this as a topic in upcoming seminars, webinars. So now, I want to thank all the attendees for giving their time, even from their busy schedule after working, they are attending this webinar and gaining the very nice informative things from you. So also want to thank my team behind the cameras, my members from volunteer team, outreach, membership for making these webinars successful. And at last, we have our AGM, which is scheduled on 27th of this month. And the location is Expo Center. You can go to our website, UAE PMI UA website, and can register in the calendar section. So you will get the email on that. Thank you everyone for joining. Thank you, Aquib, for sharing your wonderful knowledge. And thank you, the people behind the camera, Amir, and our other colleagues. Thank you, everyone.
My pleasure. My pleasure. Have a good rest of your night, guys. Thank you so much for attending.
Thank you. Thank you, everyone. Thank you, Aquib.
Bye.
Yeah.